Hey guys, Stephen Mendes here. Welcome to another video in our lecture series on education in electronics. Now, as you can see here, we have two parallel impedances, and they're both reactances because they are frequency sensitive components, a coil and a capacitor in parallel. So we use our parallel formula and we multiply the two of them on top and we add the two of them to the bottom. And we must remember at all times that J is just the square root of -1. That's all it is, nothing more. People get hung up on this J and they make all kinds of errors, but you're not going to do that. After watching this video, you're going to be a boss. Now, when we multiply J1 by minus J.5, what really happens? Well, we have J squared. And when we have J squared, the -1 becomes a +1. But the +1, because there's a minus sign here, becomes a +1. Because -1 becomes +1. So the J completely disappears and we have +1 and times 0.5. Now, that's just 0.5. So J1 times minus J.5 merely becomes 0.5. How easy can that be? Now, what happens under here now is when we have to add them, we have a whole J minus a half a J, right? So if we take away a half a J from a whole J, we get a half a J. Couldn't be easier. So what's the next step? Well, the next step is to get rid of this J in the denominator. All we have to do to get rid of that is to reverse the sign. So we multiply the J.5 by negative J.5. And what happens is, once again, we get J times J, which is -1, -1. Look at it there. And then we have a minus -1, which makes a +1. So that completely disappears, and we end up with 0.5 squared, which is just 0.5 times 0.5, which is actually 0.25, which is a real number. So we have no trouble. Now, in order to keep this the same, we have to obviously have a fraction of 1. Anything over itself is just 1, so we're not actually altering our fraction in any way, but we now have to multiply the top real number by this minus J.5 that we have here. So what is that? Well, that's just half of a 0.5J, a negative 0.5J. So that becomes a quarter. Quarter. So we just have a quarter over a quarter, which once again is 1. So we get minus J1. And you thought complex maths was hard? Come on, guys. Realize that you just have to think and move with your positive movement. Now we come to a simple parallel circuit where we have two of them once again in parallel, but one is rail and the other is a reactance. So we have 1 ohm, which is just a resistor. We're going to put that in parallel with an inductor, which is just basically half an ohm. So what do we end up with? We have 1 times J.5. Well, 1 times J.5, 1 times anything doesn't change it. 1 times anything is the thing. So we just copy back the J.5 as shown there. And away we move. Now when we have 1 plus J.5, that's real. This is imaginary, so we can't do anything about it. So we just copy that back as one complex number. Real part, imaginary part. 1 plus J.5. And you can do that anytime you have to add a real number to a complex number. Very, very easy to do. So under here now we have a complex number which we have to eliminate. So we use the same procedure we used in the last one. If we have 1 plus J.5, we have to multiply it with 1 minus j.5. So when you have a plus j.5 and a minus j.5, and the complex number is identical except that the sign of the complex part is changed, that's referred to in mathematics as the complex conjugate. Complex conjugate, remember that. So once again, we multiply the whole fraction here by, well, basically 1 over 1, which doesn't change it. So we're not changing the fraction in any case. But when we multiply it by this over this, nice things begin to happen. Really nice things. Because this here now removes the complex from the denominator. As you can see, we get 1 squared, which is the first number. And then with the second number, we get the second number squared, which is 0.5 squared, and we just add them. Why can we add them? Because once again, we have j times j, which becomes minus 1, and this negative sign turns it back into positive 1. And the beauty of positive 1 is that it doesn't change anything. So basically, it's just 1 squared plus 0.5 squared. Or you could replace those numbers with anything. If you had 25 plus j50, it would be then 25 squared plus 50 squared. Easy as pie. So when we multiply 1 by 1, we get 1. And when we multiply 0.5 by 0.5, we get 0.25. And we simply add them together to get 1.25, a simple real number, which we put to the bottom. Now up at the top, we have to multiply this conjugate here by this one by 0.5j. So obviously here we multiply the 1 by that, so it ends up being imaginary. Look, j.5 there. Now we have to multiply the j.5 times the minus j.5, which is shown here is j squared times 0.5 squared. The j squared is going to give us minus 1, and once again the negative is going to turn it back to positive 1. And we have the 0.5 squared, which gives us 0.25. The positive 1 times anything is the same thing. So therefore, we end up with 0.25. Now, notice what happens here. The imaginary part, this imaginary part becomes real. So that imaginary part there becomes this 0.25. And we just bring back add back the 0.25 over here, so, and then we put each one of them over this 1.25 denominator, and boom, there we end up with 0.2, which is the real part, and 1.5 over 1.25 is 0.4, which is the imaginary part. And you thought it was so difficult. Thanks for watching, and see you in the next video.